Okay.
Okay.
Okay. Good evening, everybody. We are just doing kind of a little bit of a soft start here to make sure everything's okay. Um, we see there's already 120 people on the stream, so welcome. We'll kind of do our official start in a few moments. Um, If somebody in the chat window could give me an indication that the audio volume is good for you guys, that would be fantastic. And you currently should be seeing our opening slide, which says the Great Conjunction. So if somebody could let me know, that would be fantastic. Um, I'm actually I'm the Gary on the slide, Gary Hawkins, and I'm with my colleague Dave Decker, who will be leading the main part of the presentation this evening with me on the telescope. And interestingly enough, we are, oh, thanks for that. The audio's good. Great. Um, we are actually still in the position where we cannot see with the naked eye Saturn and Jupiter. We're just waiting for them to appear in our bright sky here. The sun is literally just setting. In fact, I can show you what we're looking towards here. I will do that in just a second or so. It's kind of interesting. We've got lots of things going on here at the moment, like the light level is obviously dropping away on us quite quickly at the moment, and so we're having to adjust for that in real time. But I will now show you our outlook to the south-southwest. That in the distance is actually the ocean below that bright blob of light, which is the sun setting in the west. And as the evening gets a little darker here, we'll actually be able to see the position of Jupiter and Saturn on this particular picture, but we can't do that at the moment. And like I said, we are actually waiting for the two planets to become bright enough in the sky that we can actually manually align our telescope um, onto them. But in the meantime, we can start our presentation this evening. Um, and for that, I'm going to hand over to my colleague, Dave Decker. And Dave's going to run through a few slides to give you some background information, and then hopefully as that's happening, we will be able to pick up the two planets here. And if that's not the case, we'll talk about a few more things before we actually start the visual observing part of it. So I'll hand you over to Dave.
So, how's the volume, Gary?
The volume seems to be good with me.
Okay.
And if anybody on the stream, when Dave comes on, if they want the volume louder or quieter, just let me know. I'm looking at the chat window. And I will just say, once we get past the introduction, we'll be happy to answer questions as you guys have them. So please do feel free to type those in the chat window.
Okay. Welcome to the Great Conjunction as seen from an East County area in San Diego, California. Gary Hawkins is managing the telescope and the uplink tonight, which will display various views of the conjunction. As long as the planets are visible above the horizon, there are a few clouds right on the horizon. Hopefully they won't interfere until maybe at the very end of the program. So I am Dave Decker, and we are members of the San Diego Astronomy Association Outreach Special Interest Group. We wish to thank our friends for hosting this session from this great location. We're out in East County, and we have a wonderful view of the western horizon all the way to the ocean and Point Loma. So thanks for that, and it's a wonderful place to be. Here we are completely void of palm trees, eucalyptus trees, neighbors' houses, and for those of you who have followed some of our recent live stream events, you know how challenging such obstructions can be. hopefully we will not have any of those kinds of obstructions tonight. So what is the Great Conjunction? Why is this special among conjunctions, and what is a conjunction anyway? Let's begin with the last question, the definition of a celestial conjunction. Slide 2.
Yes, we're there.
Okay. So reading the various definitions of conjunctions sort of left me uninspired. I didn't really care for many of those descriptions. So let's get to what it really is. What is a conjunction? So in common terms, it's at least one solar system object and another object in the sky, which when we look at them, they are moving close together from our perspective on Earth. So we have motion, and we have the visual idea that they're coming close together from where we are on Earth here.
Oh, sorry, Dave, just for interrupting there, but I have just seen Saturn and Jupiter pop up there with the naked eye, so
Good.
we can swing the telescope onto it,
Okay.
and I'm going to do that while you continue.
Okay, great. In the meantime, we can probably go to slide number 3. Anyway, these two planets tonight are definitely not social distancing. So here we are in the COVID era, and social distancing is the key word, and these are not doing that. So what is a great conjunction? Well, it is a conjunction of the two largest planets in our solar system, Jupiter and Saturn. When these two planets are in conjunction, we call it the Great Conjunction. And this occurs about every 20 years or so, and it is due to their relative orbital periods, with Jupiter orbiting at about 11.8 years and Saturn orbiting at about 29.4 years. They are in a sequence where about every 20 years they actually come together. So the last Great Conjunction that was this close, these two planets were this close, was about 400 years ago. But at that point, it happened during the daytime, and it would not have been seen by anybody in 1623. So it was not seen. The last time that a conjunction this close was in a visible sky was about 800 years ago. So we don't have any real records of that vision, but it makes this conjunction sort of special. So anyway, Gary, how we doing?
We are doing fine, apart from the fact that these planets are I'm just trying to get them into view at the moment,
Okay.
which is the usual technical problem. I've got Saturn, so that's good news. I just haven't bumped into its pal Jupiter at the moment. Is either going to be below or maybe I've actually got I've got Jupiter here. That's what I got.
Good.
So I am not seeing Saturn, but
Well,
you carry on for a second.
let me introduce you to the two players tonight, Jupiter and Saturn. So these are the two big boys in our solar system. These are the ones that make the Great Conjunction. So a few just brief facts for those that are not familiar with them. Jupiter is the 5th planet from the Sun. It has 4 what we call Galilean moons that are large enough to be seen in a small backyard telescope like this one. They are called Io, Europa, Ganymede, and Callisto. The other player tonight is Saturn. It is the 6th planet from the Sun, and it has one moon that we might be able to see tonight. That moon is Titan. Titan is Saturn's largest moon, and it is actually the 2nd largest moon in the solar system behind Ganymede.
Okay, well, the good news, Dave, is that I now have both of my targets in my field of view here. So I will, is this a good time to
Yes,
transition
that's
over to our first shot? Okay, so, okay, fantastic. So here we go. And we've managed to get our two targets in our field of view this evening. We have Jupiter, which is to the bottom of the screen, and we have Saturn above it and slightly to the right-hand side. Um, we are hoping we are in focus. I may actually have to play a little bit with the focus of the telescope. We were focused on the moon initially, and hopefully that focus will hold. But the first thing I'm going to do here is I'm just going to zoom in a little bit more than I am already, and I am going to bring up a picture of Saturn. And here is Saturn. I think you can see you can clearly see here the central planet with the rings around it and the dark space that is between obviously the planet and the rings. What you can't see, or you can just see on one or two frames, is you can see the division in the ring. But basically, what you're able to see fairly easily, albeit that the image is moving backwards and forwards here, is the planet with the rings around it. Now, one thing I will say this evening is we're doing this in real time. So you're just basically, you are seeing real-time snapshots. In fact, we're taking these at about 6 milliseconds, snapshots of the planet, and you are seeing those through the Earth's atmosphere. So what you're actually going to see is an image that is fairly indistinct in its detail, and that moves around because there is a lot of atmosphere between ourselves and the planets, and that atmosphere is bending the light as it comes towards the telescope here, and that is causing this scintillation effect that you're seeing. But you can quite clearly see that is the planet Saturn. So I'm now going to zoom back out again, and I'm going to pick up its mate Jupiter. And here we now have Jupiter in the bottom of the field of view. And you can see that this is a very bright object. And the real challenge here of imaging these the two planets and the moons of the two planets is the fact that you need to be running at 3 different exposure times, and of course not being able to defy the law of physics with this camera. I can only run at 1 exposure time at a time. So we've taken a quick look at Saturn. I'm now going to change my exposure. I'm going to reduce my exposure so that hopefully we get a little better view of Jupiter. And there we go, kind of about there we go, kind of about there. So I'm now going to zoom into Jupiter. And interestingly enough now, right, you will have seen that Saturn, which is still here, has almost completely disappeared. You can see how much more light is coming off Jupiter, is being reflected from the sun than is being reflected from Saturn. So I'm now going to zoom into Jupiter, and we'll take a little bit of a closer look at Jupiter. Here we go. And again, the amount of detail is fairly limited here, but I think you can see every now and again, you can see some of the banding on Saturn there as the picture comes in and out of focus associated with the atmospheric scintillation. And just to remind you of what those two planets actually look like, if you're able to get a really nice shot of them, let's just go back to the slide that we left earlier on, and you can now see the full glory of both Jupiter and Saturn. Jupiter with its many bands of cloud and the red spot, and Saturn with its bands and also the rings, and the main ring separated by what's known as the Cassini belt. Okay, so I am now.
So, Gary,
Yes,
we've had some questions about where are we looking in the sky.
yes,
Maybe the e-finder would be a good way to show that.
yeah. Let me bring up the eFinder. and we will transition across to our shot of the E-finder. It is getting darker here now, so I am going to just increase the exposure a little bit on the E-finder so that we can see a little bit more detail. So bear with me. Okay, let's bring my E-finder up. Here we go. All right. And so if we are looking at this particular picture, um, this is, we're located approximately in Spring Valley. Well, we are in Spring Valley. We're not approximately anywhere.
Blossom Valley.
Blossom Valley. We're in
Yes.
Blossom Valley. We're about 1,800 feet above sea level here. We actually, the horizon is below us, which is kind of interesting. We don't often get that when we're astronomers, where we're looking down on the horizon. Um, and where and I've now put up on the screen, where we're looking at. If you look at this particular diagram, um, the the center point is not quite west. The west is slightly to the right of the center point of this diagram, and the planets, which are currently not showing. Let me see if I can bring them up, and it's still too light here at the moment for the. Oh no, I think there they are. There they are. I think that's them there. There they go. And here, now you can just see Jupiter and Saturn. I'm going to see if I can. I am not sure. Can somebody tell me, are they seeing my cursor on the image? I don't think you guys are. But let me describe where it is. So I can see Saturn and Jupiter. If you look down at the black horizon, you'll see that there is a small group of white lights just below the horizon. If you go up through the white area, you go up about the same distance again and then go slightly left in the sky, you will see a faint point of light. And that is Saturn and Jupiter, which are appearing to us with the naked eye as a single point of light. That is Saturn and Jupiter. So did anybody manage to... Oh, the cursor was visible. Okay, so if the cursor is visible, it is approximately... you go up, across. I think it's approximately there. And if that, and maybe actually the cursor needs to be on the air screen. Hold on a second. Here we go. Let's try that one. That. So if you guys are seeing the cursor now, that is Saturn and Jupiter where my arrow is pointing. So pretty low in the sky, about 20 degrees above the horizon. Okay, so okay, hopefully you saw it. So a few shout outs here. I noticed some familiar names on the stream. DJ, great to see you again. I'm sure, let's have a look. I'm sure there were some other names that I'm familiar with. We at the San Diego Astronomy Association live stream on a fairly regular basis. Margaret, great to see you again. And we kind of get to know some of you folks, which is tremendous. Although we do have a lot of people on the stream tonight. We just peaked there at 500, so that's
Yes.
fantastic. And if you guys want to, particularly those of you who are perhaps not in the US, if you want to type your location in, that would be absolutely fantastic. So name and location would be great. So let me go.
So we have two more slides we could do.
Yep.
While we're waiting for the sky to get a little darker.
Okay.
So slide 4 would be.
Yes.
Yes, there we go.
So I just need to transition that across, Dave. Yep. So slide 4 is now up.
Okay. So you will be seeing here a graphic. This graphic demonstrates the relative positions of these two planets for the last several weeks, I think beginning December or so. And as you can see, they appear to be moving towards each other on a daily basis, making this nice V on the graphic. And we are right down at the bottom of that V tonight. So the question has been asked, when exactly is the closest approach? Well, it turns out that the actual closest approach of these two planets occurred earlier today. That's December 21st, 2020, at about 10:20 a.m. Pacific Standard Time. So that's when they were actually closest together in the sky. Now, that's not going to hurt our view at all tonight because they've only increased a few seconds of arc between the two of them since 10:20 this morning. Slide 5.
Yes, slide 5. And I'll just say, because I put this one
Yes.
together.
Yes,
So
that'd be
yeah,
good.
so there's been obviously quite a lot of excitement in both the news, on the social media platforms, and certainly in our astronomy club with respect to this conjunction. And so we saw quite a few pictures this morning being posted by some of our members. So I grabbed one of these pictures and put a compilation up. And here we have one of our members. It is Michael, I believe. Unfortunately, I've got my, let me just bring that up. Yes, it's Michael Sherman, who provided these pictures. And he was actually out viewing the conjunction last night. So just when the planets were a little bit more separated, and took these pictures at the lagoon close to the ocean here. Kind of interesting picture. He did a very nice double exposure here of him dressed as Santa Claus, looking out towards the planets in the sky. And these were the two planets are obviously as they showed last night. And just to give you a comparison of how close these two planets are currently, he also included this graphic of the moon. And you can see this is a thin slice of the moon. And that is basically on the same scale. So it kind of gives you an idea as of yesterday how close the planets are. And in fact, they are even closer together today. Although I must say now, now that the light is beginning to fade even more here, Dave, can I actually see both of those with the naked eye separately again?
Yes. With the naked eye, I can currently see Saturn and Jupiter.
Yeah. So I can actually, so actually they're not actually showing as a single point of light. They are still separated to the point where you can see them as two separate points of light. And Jupiter, with the naked eye, as I look out here to the southwest, is the lower of those two, and Saturn is just above it and to the right, much dimmer, but you can actually make them out. Okay, so let me bring up, let's go back to another view of the planets here, Dave, and then we'll. Oh, that's interesting. So, and the reason that's interesting is we are using a very narrow field of views for on our telescope here, so that you guys can get to see some a large image or large-ish image of the two planets. And unfortunately, the two planets have drifted out of my field of view here, so I'm going to have to correct for that. So I am going to let's see if we. I'm going to give you another slide. Well, in fact, I'm going to give you another slide just to look at. These are two pictures of Saturn and Jupiter that were actually taken with the equipment that we are using tonight. And you may wonder why we're not seeing these quality of images. What I can tell you is, in order to get these two pictures, I basically had to take about 3,000 or 4,000 images of each. Of those images, I selected about the best 20%. Those images then went through 3 sets of software to process them, and out pops about 15 or 20 minutes later the pictures that you're viewing. But the equipment that we're using tonight and the raw images that you've already seen would be sufficient to provide this type of quality of picture if we were able to do that processing in a 15-minute or so time frame, which of course in a live stream is somewhat difficult. But I did want to point that out. So let me see if I can acquire my targets here, Dave, again, and I will.
Well, in the meantime, I can give you some more detailed information about our two players here.
Yep, that'd be great.
That work? Okay.
Yep.
Let's start with Jupiter, the fifth planet from the Sun, as I said earlier. Um, its distance from the Sun averages about 470 million miles. That's about 5 AU. And an AU is an astronomical unit, which is the average distance of the Sun to Earth. So Jupiter is about 5 times farther from the Sun than Earth is on average. Today, we are about 550 million miles from Jupiter. It is on the opposite side of the Sun, so it is a little bit further than its actual orbital size. Mass of Jupiter is about 318 times the mass of Earth, quite a bit bigger. It has a gravity of about 2.5 Gs, or 2.5 times the gravity of on the surface of Earth. Although it is a gas giant, so it'd be pretty hard to stand on. But if you were at that interface, that's what the gravity would be. Jupiter has a weird problem that we've been trying to explain in the last decade or so. It has a very strange and strong magnetic field. And in fact, we have an orbital research project going at Jupiter right now called Juno. And the Juno exploration was sent to figure out this funny magnetic field. The weird thing about the magnetic field on Jupiter is that it has 3 poles instead of 2. So they're mapping this very carefully, trying to figure out exactly what is causing this interesting weird thing to happen. Jupiter, because it is the largest planet in the solar system with a lot of gravity, has often been called the protector of the inner solar system, because there are many comets and asteroids coming from the outer areas of the solar system headed towards that big gravity well, the Sun, in the middle. And if they were all allowed to enter the center part of the solar system, then the inner planets, Mercury, Venus, Earth, and Mars, would be bombarded by a whole lot more asteroids than what we actually see. What happens is Jupiter, with its large gravity well, sweeps up a lot of these outer artifacts coming in and acts sort of like a vacuum cleaner to protect the inner solar system. So it plays a very important role for us.
Okay, Dave. So I've actually found our targets again, which is good news. And I am now very much overexposing my image, so apologies as I just try and get this right, folks, on the live stream there. But I've now actually got I'm now actually showing the moons.
I see that.
So we've got Jupiter, which is here, and hopefully you can see my cursor. And if you can't see my cursor, it's in the is the lower of the 2 bright planets there, and you can see 4 of the moons with Jupiter, 2 on one side and 2 on the other. The second one being considerably further out. And then above that you can see Saturn, and you can see 2 fairly bright moons. You can see those fairly easily. And there is a much dimmer moon. In fact, there's a much dimmer moon to the lower left-hand side, quite close in, and it's possible that there may also be a moon that's on the upper right-hand side, but I'm not 100% sure about that. But we can certainly see 3 of the moons of Saturn and 4 of the moons of Jupiter. And Dave, can you tell us which?
Yes. So in your view, Um, Jupiter is the brighter of the two planets. There are three moons apparently close to Jupiter in the view there. On the far left is Callisto, and then on the second on the left is Io, and then the one just to the right of the planet is Europa. So the obvious one missing is Ganymede, which in fact is the largest of the moons, but we cannot see Ganymede because it currently is in transit across the face of Jupiter. Now, if we were set up for planetary imaging tonight, and we could take Jupiter and make that our entire field of view, then what you would see is you might see Ganymede, but you probably would see the shadow of Ganymede going across the face of Jupiter. And that usually takes only about maybe a couple of hours to traverse the whole planet. So we call that a shadow transit. That's actually happening tonight, but you will not be able to see it in the view that we have here.
And interestingly enough, Dave, if I just go back to the slide that I showed earlier on, which were two images of Saturn and Jupiter taken when they were considerably higher in the sky from my back garden in San Diego, we do actually see a transit taking place there. If you look at the image of Jupiter, you will see a black spot slightly below the center on the left-hand side. And that is not the red spot. That is actually the shadow of one of the moons passing in front of the passing across Jupiter. And I believe the moon that caused that is the one that you can actually see in the shot there on the lower left-hand side. So that is what you typically see if a moon is transiting across Jupiter. You often see the shadow formed by that moon on its surface. So I will now take us back to the other real-time picture. Okay, bring these back in, and I'm gonna just play. I'm gonna play with the exposure just a little bit. I'm having to, as you can see online, having to reposition my planets a little bit in the view because they are. My telescope here is not perfectly polar aligned because when we set the telescope up, obviously we didn't have the pole star to polar align to, so we had to just do a manual alignment, and it's fairly close, but it's not 100% close, and so consequently, even though my telescope is tracking with the Earth's rotation, it's not tracking perfectly. So I'm going to increase the exposure again just a little bit here. It's going to blow a lot of this image out, but I'm going to see if we can spot any more moons in
So let me interrupt for a second.
Sure.
In the view that you're seeing now, uh, the star or the object to the far right, a little bit lower than Jupiter, that is not one of the moons. That is just a background field star. Also, there's a fairly bright object about halfway between Saturn and Callisto, just above Jupiter in that area. That also is a background star. So those two are not moons. But the object just above Saturn is probably Titan, although I can't confirm, but I believe it would be Titan, which is the one moon that we usually see when we're observing Saturn because it is much larger than all of the other moons of Saturn. Gary?
Okay, great. And we are certainly well overexposed at the moment here, but you can actually, as Dave said now, not only can you see the moons appearing, but we're also beginning to see some of the background stars appearing in our picture as well. So let me just reduce my exposure, and I'm going to try and come down to the fact where we perhaps get some detail. Here we go. Actually, just as we came through there, let me just bring that up. There's actually the atmosphere is actually quite stable now, and you can see Saturn there with its rings just slightly, just moving slightly, but the atmosphere is actually definitely got somewhat more stable from where we were couple of moments ago. And the interesting thing as well now is you're actually going to see some color variations on the planets. And again, this is associated with the fact that the planets are very low on the horizon, or very low in the sky, probably between 15 and 20 degrees at the moment. So we're looking through a lot of atmosphere, and that's causing some distortion of the light as it comes through. And as my camera tries to compensate for that, it sometimes overcompensates a little bit, and so consequently it causes the colors sometimes to sort of you will have seen Saturn gone quite red. It's kind of showing a little greeny blue at the moment, and that's the camera struggling with the fact that the atmosphere is playing around so much with the image as it comes in. Normally, if we're actually doing planetary imaging, we would never image a planet this low in the sky. We would normally image the planet when it's much higher in the sky. So I'm going to just fade Saturn out a little bit, and there we've got Jupiter come back in again. And I think just briefly there we were able to see about two or three of the cloud bands on Jupiter. Let me just see if I can zoom in so we can get slightly. There we go. And I think there you can certainly see two cloud bands there in the middle. As you get the odd good image coming in. And it's kind of amazing, right, that the images that I showed you earlier on, these two images here, these are literally the software that we use in order to do this planetary imaging can take an image that looks like this, and if you capture enough frames and do enough processing, you can actually turn it into an image that looks like that, which is it's pretty impressive. But it's not something, unfortunately, we can do in real time, so we can't show you that this evening. So I will zoom back out again, and let's go take a look at where we are in the sky, Dave.
Okay, and a couple of questions that have come up. One of them was, when you're looking at the full view off your main camera, what is the field of view? The question was, what is the magnification? But we could give them the full field of view, which is it a half a degree?
No, actually, the camera is set up at the moment. If I didn't have any zoom applied, it would be set up for about 0.3 of a degree. But because I've actually got some zoom applied as well, I'm guessing that we're running at about 0.2 of a degree.
Yeah.
That would be my guess.
Okay. And the other question, which we talked about a little earlier, and I think someone may have already answered, is that the closest point of conjunction occurred about 10:20 a.m. today. So that's been this morning. And but the difference between that view and what we see right now is negligible. In other words, it would not have looked any closer at 10:20 than it does right now. Right here, it's about 6 minutes of arc apart, and it was only a couple of seconds of arc closer at 10:20 this morning. So this is about as close as you're going to see with this great conjunction.
Yes, okay. And yes, we had a comment there. Can we see the moons again? Yes, I will bring the moons up again for you in a few seconds. But first, let's just take another look through our e-finder. And so now, as it's beginning to get darker here, you can see the horizon a lot more clearly. You can see the twinkling lights to the northern part of San Diego City. This is actually that's Tom.
That would be Point Loma.
That would be Point Loma, right?
Yes.
So we're actually looking out towards the famous landmark of Point Loma, and you can clearly see now Saturn and Jupiter as a single point of light on this particular image. Off the horizon there and coming down towards the horizon. Right, so I'm going to set my planetary image up again. So I will do that and then I will bring that up on the screen. So just bear with me. Okay, and for to answer the question or to respond to the chat request, I am actually going to overexpose the image so that we can once again see the moons, and I am just going to reposition a little bit because they are drifting on me quite quickly at times here, and so I just have to give the scope a little nudge so that we can see
So we
it.
have a question about relationship to the moon. Um, the moon is way up and to the left in this view. So even in the wide angle view that you're looking at, um, we're not able to get up there to the moon.
No, currently we are not able to, but if anybody is interested as we get to the end of the live stream this evening, I will swing the telescope onto the moon briefly, and what we, the amount of magnification, if you like, that we've got running uh, um, is such that we won't be able to see the entire moon because we'll be zoomed in on part of it, but I'd be happy to bring up a picture. So I am just going to transition now across to our picture again of Saturn with its partner Jupiter and several of the moons. Again, I think we can see the three moons of Saturn there. Okay.
I think what we're actually seeing, well, one for sure would be just above Saturn. That would be Titan.
Okay.
The object below and to the left is a field star,
Okay. Okay.
and I am not able to, not sure about anything else. Also, the star again on the far right in that image is another field star.
Okay. Just you carry on for 1 second.
Sure. So of the four big moons of Jupiter, we can see three of them. And I said before, the moon Ganymede is in transit across the planet, and we're not going to be able to see that in our view here tonight. So that would be a pretty difficult thing to do. Those four moons are the four moons that Galileo discovered in about 1610. And in Galileo's notes, he sketched the positions of the moons over many days and many weeks, actually. And he noticed that they were in various positions. They changed a lot. This was something that uh, was very curious to him. And what he realized, of course, is ultimately that these moons were in orbit around Jupiter. So that was a very important discovery on his part. And his sketches and his notes demonstrate the work that he did in these moons themselves. So these are the same four moons that we ordinarily see around Jupiter, and we call them the Galilean moons. Gary?
Yeah, and I just had to step away there. One of the things that I'd forgot to do was get my headlight here, and as it gets darker, it's getting difficult to see the notes. So again, I am just going to reposition um, our picture there, and we're going to mention a few other things about this evening, which hopefully you'll find interesting. And again, if you've got any questions, please feel free to ask them on the chat line. So, and to do that, I'm just going to bring up a few prompts for me, and yes. So, yeah, this is kind of what we're seeing this evening. This conjunction occurs when Saturn, which is a considerable distance beyond Jupiter, and Jupiter all align from where we are on the Earth. And the moon is in the sky tonight, high on the left-hand side, and the sun is has set now on the right-hand side of our image. And again, the last time that what you, that you were seeing, the last time this could be seen with this conjunction so close was 800 years ago. So it's a real treat that we're seeing it this evening. Um, and also, today is the winter solstice. For those of you who might not have realized, and the winter solstice is for us the shortest day or the longest night. And if you live in the southern hemisphere, of course, it's the longest day and the shortest night. And you may have picked up from the fact that I am originally from a different country. I am actually English, and so I just thought I would mention the solstice, which is actually which is what I say widely celebrated, but it's certainly celebrated in the UK by a group called the Druids. And the Druids and the Wiccans are celebrating the Yule holiday as opposed to Christmas or Hanukkah or Kwanzaa, etc., etc. So they are celebrating one of eight one of eight holidays in the solar calendar called the Yule holiday, and it's typically a time that friends and family exchange gifts in honor of the sun. Homes are decorated with red, green, and white decorations, colors that hark back to Druidic traditions. And the picture you see on your screen there is one of the most famous celebrations that takes place on an annual basis in Stonehenge, and Druids, as many as 2 to 3 thousand Druids come together each year and watch the sun rise or set um, at Stonehenge, which for the Druids is a very important place. Although it does seem to have been proven that there was the thought that Stonehenge was actually created by the Druids as a temple, but Stonehenge has actually been dated considerably before the time that the Druids came to fruition, so that seems unlikely. Similar celebrations take place at other ancient sites such as New Grange in Ireland and also Sierra de Gentil Pyramid in Peru. So that's the winter solstice taking place today. And it's also a big day in the astrology calendar. Conjunctions typically in astrology are considered to be pretty important and feature a lot in astrological predictions. The conjunction of Saturn and Jupiter takes place on a regular sort of 19 to 20 year schedule, but a close conjunction, as we're seeing this evening, takes place on a much more infrequent 4 to 800 year cycle. And for that reason, the conjunction that's taking place today from an astrological point of view is extremely important. Jupiter, as I understand it, and I'm not an astrologist, but is supposed to represent optimism, enthusiasm, and vision, but its energy sometimes doesn't understand when to stop. Saturn, on the other hand, is about stability, patience, tenacity, and discipline, but this energy is often very resistant to change and stuck in the old ways and overly authoritarian. And the conjunction is said to free Saturn's hardworking ethos from its own strict constraints, enabling its energy to be more productive. And from Jupiter's perspective, Saturn can impose much needed boundaries so that Jupiter's optimism can operate within the useful structure instead of running wild. Perhaps the most important thing out of all of that is the fact that when Jupiter tries to bring things, Saturn tries to end or contain them. When the two energies are blended in astrology, they are in the as they are in the Jupiter-Saturn conjunction, we are able to harness the best of both in order to bring about much needed change. And after the year that we've had in 2020 with the pandemic, I can only hope that that is true. That is the conjunction from an astrological point of view. And then finally, just to, I guess, address one other thing that certainly made some press, Dave, is the Christmas star and whether
Yeah.
this is actually the Christmas star. So I'll let you comment on that to start
Uh,
with.
there has been much publication in the media, all sorts of things about this conjunction being the Christmas star or the Star of Bethlehem. And there's been a lot of conjecture over the years about what the Star of Bethlehem is. The Star of Bethlehem was described in the Bible, in the Gospel of Matthew, as part of the Christmas story, and it was said to have guided wise men who followed the star in the east, and they ended up at Bethlehem. So there have been many attempts to identify this particular celestial event and correlate it with that particular scripture. And one of the common descriptions of the possibility is that the Bethlehem star, the Christmas star, was in fact a conjunction of the two big planets, or a great conjunction, which is what we're looking at tonight. Um, so that certainly could be a possibility. It turns out that there was a great conjunction in about the year 7 BC. And, there is that possibility that, and some have argued that it could actually be, um, the object referred to in the story, in the Christmas story. But there's lots of other possible explanations for that. First of all, um, if you are trying to find that particular object, why would you not consider a supernova? A supernova would certainly be a suddenly appearing, extremely bright star. Some supernovas can be seen in the daytime, and we may not be able to find the remnants of that supernova today if it was in such a situation that we can't find that remnant. So there's lots of possibilities to explain that, but you will see in the media the words Christmas star or Star of Bethlehem referring to tonight's event. And that is not a fact. That is a supposition. It certainly is a possibility, but I leave it to you to figure out the significance of that correlation between our great conjunction that we're seeing tonight and the Star of Bethlehem.
Yeah,
Yeah.
those are some great points, Dave. And um, I think, and again, it's nice to think this would be the Christmas star, but there's been quite a bit of, let's say, scientific work tracking back the conjunctions, and the nearest great conjunction that we have to that time is actually 7 BC, so 7 years before the birth of Christ. I think, in all likelihood, it seems to me as though a supernova event would be much more likely the explanation for what the Star of Bethlehem was. Um, that certainly could have shown in the sky very brightly, certainly way brighter than any of the planets that we see today, and would have been an incredible sight. And as Dave said, the remnants of that supernova may actually be quite difficult to see in our sky, so it is quite possible. A couple of things came up on the chat there. We had a request to make Saturn a little bit more viewable, so I brought down the exposure. I will zoom in there, and I think again you can quite clearly see the planetary core with the rings around it. If you didn't catch it earlier, that movement that you're seeing in the oh
Oh, crap.
uh, that movement that you're seeing What happened there, Dave? I'm hoping we're still streaming. I need to check a few things here. I've certainly lost my tracking. Um, all right, hold on. What's going on? Sorry, we've had a slight technical problem there, guys. All right, I need to bring that zoom back quickly because otherwise I'm going to lose these guys really quickly. Right. As you can see, and I'm hoping you can still hear. Um, all right, we had a glitch there. Okay, so it looks like we may have had a power glitch. And that has caused a problem in so much as it may have brought the telescope. Oh, the telescope's still working. Okay, maybe I'm still good. I panicked there because my planet started shooting off the screen here. It looked like the
Yeah,
tracking.
yeah. I think it has one of these cables was the issue.
Okay,
Yeah,
okay. I think we're still good. Apparently they can still hear me and YouTube is telling me the stream is still going, so I guess we're good. Right. So what I was trying to do there was to zoom in on Saturn. There we go. I was trying to zoom in on Saturn so that we could take a bigger look at him. There we go. And there is a picture of Saturn on your screen at the moment. I can even bring it up a little larger. Wow. It's a little bit of a pixelated image because we really are zoomed in now. I am saying that I'm going to guess here, but 250. We are probably down to well less than zero point 0.1 of a degree now in terms of field of view, probably even 30 seconds of arc or something. It's pretty small. But we're seeing a nice picture of Saturn there, albeit we're not seeing too much detail. Again, you can see that really strong the planetary core with the rings around it. And for those that weren't on earlier, you would have heard me talk about atmospheric scintillation. That is what is causing this image to fluctuate because we are looking through a huge amount of atmosphere between where we are with our telescope and where Saturn is very low on the horizon, probably about 18 or 17 degrees or something at the moment. So there's a lot of atmosphere between us and it in the Earth's atmosphere, and that is causing a distortion of the light. And we refer to this in astronomical terms as seeing. When the seeing is really good, this image will be really stable. When the seeing is poor, this image will vary all over the place. And I would say probably tonight we're sort of seeing average imaging. So that's Saturn. It's fuzzy because of the atmosphere. Yes, you're quite right, JL. And there was another question to say, can we see this tomorrow? Yes, you can. The two planets are still going to be relatively close to each other tomorrow and the day after. So if you've not had the opportunity because of bad weather, get your telescope out and take a look if you can. I know some of the other organizations have actually been running live streams on different days. So I'm now going to try and do the same thing now for Jupiter. I'm going to zoom back out here. I'm going to come in, I'm going to take a look at Jupiter. First of all, I'm going to bring our exposure down so that we can actually hopefully see some detail on Jupiter. There we go. As we kind of get detail on Jupiter, we completely lose Saturn because it's only about 20% of the brightness of Jupiter. And I'm going to zoom in. Completely missed that. Oh, there it is. And once again, I'm going to go up to about the same level of magnification. So there we go. So you can see that Jupiter appears as a larger object to us. Now, unfortunately, I don't think we're going to see much more detail than we're seeing at the moment. As Saturn and Jupiter get lower and lower on the horizon, or towards the horizon, we will see less and less detail because the atmosphere is playing more and more with our images, so to speak. But that is Jupiter. If you've got really good eyes and a little bit of imagination, you can see the two bands there that run across the planet. They are practically horizontal, and just as the image sort of comes into focus just briefly, you can see the two bands. And again, if in going back to one of those earlier pictures I showed you, if I was taking 3 or 4,000 of these images and then I take them offline and start post-processing them, I can actually produce quite a nice rendition of what this particular planet
Gary,
looks like. Yes.
if you were able to see the belts of Jupiter clearly and the moons, you would realize that the belts and the moons sort of define the planetary equatorial plane of the planet, and so that the orbits of Jupiter's moons are pretty much in the same plane as the belts on the planet itself. So pretty traditional kind of an orientation, and unfortunately, I don't think we can see the belts and the moons in the same view tonight. But actually, if you look at it visually with a reasonable size scope, you will be able to see the belts and the moons all at the same time and see how that correlates pretty well.
Yeah, that is interesting actually. If you do look at this visually, you will actually see not only the planets but the moons, whereas the camera, because it is a relatively precise device, is very dependent upon the light level coming in. And as I said earlier on, Saturn is coming in at only 20% of the light level of Jupiter, and the moons are coming even less. So the guys who are actually producing some of these nice images that you might see on Facebook tomorrow, they will have actually have taken 3 sets of exposures at 3 different exposure times, and then brought the images and combined the images together in order to give you the pictures that you'll probably in all likelihood see on Facebook tomorrow. So yes, it is a bit of a challenge if you're trying to do this from a photographic perspective. But we can see Saturn there. You can see Saturn. The rings are nicely defined around the planet, and I'm now going to just bring that exposure up again to so that we can start seeing these moons more clearly. So there's okay, so I can see at least 3 of Jupiter's moons, and we can see Titan up and to the right, I believe, on Saturn. Is that right, Dave?
Yes.
Yes. Okay, great. Okay.
Did
Any
you?
more?
We could go to the next slide if you want to.
Sure. Let me.
It's other conjunctions.
Oh yeah, sure. Let me bring up this slide,
Sure.
and we will. Yep, we're good.
We're good?
Hmm.
Okay. So other conjunctions. Conjunctions in the sky are a fairly common occurrence. Astronomers look at these things all the time. They observe them, they track them, and very close conjunctions they're interested because you can see the relative distance and the movement between the two objects and so forth. So here's a picture of another conjunction. This is a photograph that I took from Sunrise Highway on May 26th of 2013. And it is a conjunction of 3 items in the sky. You may have to look closely to see those 3 dots above that beautiful horizon, but I can see them on my cell phone, so I'm pretty sure you can see them on your computer. Those 3 dots are in fact planets. So a conjunction is formed by solar system objects. It has to have at least one solar system object because stars don't move against the background, in the human time frame. So we can't watch stars move towards each other or away from each other on the human scale in our lifetime. We can measure them scientifically, but we can't actually see that. But things in a solar system like planets, moons, comets, asteroids, these things are moving pretty rapidly, and we can see them easily in human time as we are watching them tonight. If we could watch the moons of Jupiter for about 2 or 3 hours, you would see that Ganymede would come across and be visible on the right-hand side, and you would see that the other moons would change positions. Io would probably disappear, and you would see, oh my gosh, those moons are in a totally different orientation. If we were to look at the images taken last night, just 24 hours ago, of this same conjunction, we would see that there were 2 moons on the right and 2 on the left, and their spacing was completely different. That's because solar system objects move in human time, and we can see these conjunctions appear. So this image I took from Sunrise Highway is a conjunction. The planet on the left is Jupiter, our favorite guy tonight. At that time, Jupiter was about 560 million miles from Earth. The planet on the top of that triangle, was Mercury. Mercury we can see in the western horizon. It's always in the western horizon when we see it, and sometimes it actually looks fairly bright. So here is Mercury. At that time, it was about 105 million miles from Earth, much, much closer than Jupiter. On the bottom is Venus. Venus can be extremely bright at times. At this point, Venus was about 152 million miles from Earth. So these 3 planets formed this interesting conjunction on May 26th of 2013, and it just begged to be imaged. And I drove up to Sunrise Highway, found this spot, and took this image. But there's one more surprise in this image.
Hold on, Dave. Let me just transition back to the image for a second there. Yep, go on.
We good?
Yep, we're good.
Okay. So there's one more surprise in this image, and that is that there's actually a 4th planet visible. And guess which one that is? It is the horizon itself, which is Earth. So here we have an image of Jupiter, Mercury, Venus, and Earth, all in the evening sunset twilight. Thank you, Ray.
Okay, cool. And we had another question online here. Can we identify the moons? So let's go back to our image here. And yes, I can. I'm not sure if I can. I don't think I can get my cursor going here, so we're going to have to do this. Let's start with Jupiter, which is the lowest planet. The moon to the left-hand side is Castillo. The moon that then the next moon in, I believe, is Io. There is then another moon which is very, very close to Jupiter called Thebe.
Excuse me?
Is it called Thebe?
Oh.
Am I pronouncing that correctly? But you can't see that on this. So let me just do the ones you can see. So we've got Castillo. Coming in closer to Jupiter on the left-hand side, we've got Io. In transit going across Jupiter at the moment that you can't actually see is the largest moon, Ganymede. And then on the other side, on the right-hand side, is the moon Europa. And then in the far... There should be another... okay, so I think that's correct. And then if we go up to Saturn, which is your top image, which is desperately trying to drift off the screen here. So let me just go and wrangle it here and bring it down. Oops, got it going the wrong way. Got it going to the side. So let's just try and slow down here, Gary. Okay, so we're just going to bring Saturn down a little bit as soon as I can. There we go. Right. Now the moons that you can see on Saturn, if I've got this correct, are... You can certainly see Titan. Titan is the moon that is high and to the right of Saturn. I believe the moon that is low and to the left is Rhea. And I believe what we and either there's a field star there's probably a field star that if you go further left and low, I believe that's a field star. So I think we can only see the two moons of Saturn and currently the three or four moons of Jupiter to answer the question. Okay, right. Let's just go to our eFinder view again and see where we are with respect to the horizon. And here is our eFinder view again. You can see as the telescope drops down, the horizon is kind of going up in the screen and Jupiter is getting lower in the sky. Let me also perhaps just do a little bit of modification, bring up the gain a little bit. It's getting darker and darker here now in the East County. So I'm just going to need to just tweak that a little bit so that you can see. Here we go. Yeah. So in fact you can see actually kind of interestingly enough, right? You can actually see our lights here playing on the grass in front of us, just playing in the foreground there. And you can also see Jupiter and Saturn now quite close, beginning to get quite close to the horizon. And you can see the really the twinkling lights there of San Diego. And in fact, what I'm actually going to do here is I'm going to put the gain up on this camera a little bit, and so that you can actually, there we go, so we can actually perhaps see some of those twinkling lights. It's kind of nice when you're imaging. Oh, and in fact, we can actually see a couple of aircraft now. I was hoping to catch a couple of those. Low on the horizon here, you can see that light moving from right to left, low on the horizon, just going towards Jupiter and Saturn. That is one of the planes getting ready to circle in and probably land at San Diego Airport. So yes, kind of nice. This viewfinder view kind of puts everything in context for us. Right, we will now go back to our image of the planets. Whoops, didn't mean to do that. My apologies. Okay, and I will transition across to that as soon as I've got the image set up correctly. Right, do we have any more questions? We were planning to run for about an hour this evening. We've actually gone past that now by a few minutes. It's not that we're in a desperate hurry to get home or anything, but if you guys have got any additional questions, we'd love to take them before we call it a day here. And if anybody does want to take a look at the moon, I do not mind swinging onto the moon as well. Dave, do you want to?
We can try that. While you're working on that, there was a question that came across that says, when will the conjunction happen in Texas? Well, it's happening right now. And whatever time it is in Texas right now, you may find that it's below your horizon. I'm not sure. But the conjunction doesn't care which way the world is facing. It's going to happen, and we're actually doing this live. And if you're watching it live, then this is what you have. In Texas, maybe you can tell me in chat, is Jupiter below the horizon at this time? It may have already set. I'm not sure what your schedule is there.
Yes. Yes, it's all happening right now, and the conjunction will still be viewable, well, really for the next couple of days. If any of you guys have got a small telescope or even a pair of binoculars, it's worth getting out there and taking a look, because literally this is, well, it's certainly a once-in-a-lifetime event. The last time this happened this closely was 800 years ago when it could actually be seen. I believe that was around 1253 or some 1252, something like that.
Mm-hmm.
And then there was another event in the 1600s but the sun was played a role in that in so much as it was too bright for you to actually see the conjunction. Okay, so I'm going to transition for one more look at our planets here, and there they are in their glory. We have Jupiter and three of its moons, and above that we have Saturn. I'm going to reduce the exposure a little bit so that we actually lose the moons and get a little bit more detail on the planets. And we'll probably make this our closing shot of the evening on. Here we go. I'm just easing the exposure back here so that we can actually see the rings on Saturn. There we go. Whoops, just missed it. There we go. And we'll probably make this our closing shot of the evening. And we'll go from there. Right, let me hold on. Let me just bring this more into. There we go. I'm going to center those up nicely in the image. And then just for, since we have the moon and we have a telescope that is got some pretty high magnification on it, I think we will just swing onto the moon for a few minutes. I'm certainly not an expert on the moon, but I'm happy to give you a quick look at the moon. It's probably about 50% in its cycle at the moment, so we should be able to get some nice pictures of some of the craters and the sea areas here. So, okay, so I think we will now make that transition. We'll do another quick look at the E-finder, and here we have Jupiter and Saturn in the distance there, sinking towards the San Diego horizon. That is Point Loma in the distance there, where the slightly you see the area of bright light on the horizon there. Slightly to the right-hand side of that is Point Loma, a very iconic landmark, and the planets are beginning to set towards that. And as we've already seen several times this evening, these are the stars in our great conjunction, the fifth and the sixth planets in the solar system, Jupiter and Saturn. And so with that, I think I will now attempt to manually bring the scope round onto the moon, so that we can spend 5 minutes looking at the moon. And I think then this would be an ideal time to wrap up our presentation for this evening. So we're going to, is there anything you want to talk about while I bring onto the moon?
I think we've actually covered most of the slide deck,
Okay.
most of those things. I'm looking at the.
Well, I tell you what, why don't I then, I'm just going to go back into my slide deck here, and I'm going to bring up two major players so that we've got, you can actually see those two major players. And then I am going to I'm going to slew my telescope now and bring it onto the moon. I'm probably going to need to do a little bit of manual adjustment as well, so it's going to take me a minute or so. So just bear with me here as we just set up for our final shots of the evening before we take our live stream down. And all I got to do now is find where the moon is. And in order to do that, what I'm actually doing is I have an program running on my PC, which is a star map. It shows me all the different targets in the night sky. I've found the moon, and I'm now commanding my scope to swing towards the moon. And it's just repositioning itself now. So we are hopefully going to get some. I think we're good, Dave.
Oh, good. Okay.
I think we're good. So I just need now to. I think my microphone lead is long
Watch
enough.
that power cord.
Oh yeah, don't want to be stepping on the
Yeah.
power cord, do we? I think my microphone cord is long enough here that I can get it.
So while Gary is getting lined up on the moon here, the moon tonight is at first quarter. So it's about 7.5 days old, something like that. And so we see half the moon. And tonight we see some nice features on that half of the moon. When we get over there, we can point them out a little bit greater. But one of the things that we see is the Sea of Tranquility. So any of you out there who were around in 1969 might remember the Sea of Tranquility. That is where Apollo 11 landed and first set foot on the moon. So that will be pretty much centrally located in the bright half of the moon that we see tonight. Then to the right of the Sea of Tranquility, we see a nice, large, round, dark area that we call a Merecrisium. It's a nice object to take a look at and to get oriented when we're trying to find our way around on the moon.
And I must say there, Dave was looking at me as though he'd just seen a ghost, and that was because I had just put my foot on the power cable and he was concerned that we were going to lose everything. I could see that. Look on his face was just like sheer terror came across his face there as I put my foot right on top of the power cable. Right, so I think I am about ready, Dave, to switch over to the moon. So let me do that. And yeah, voila. And here we have a large image of the moon. So just to, normally the way my telescope is set up, I have a half a degree field of view, and the moon is half a degree, and fits very nicely in that field of view. So you get to see the whole moon. But obviously, because this evening we were trying to image two very small planets, I took out several components in the optical chain that obviously gave us much more magnification. And so what you're seeing here is the effect of that. My field of view is probably only about 0.2 of a degree, and so we probably are seeing less than a quarter of the moon at any given point here. So I will need to maneuver around, so to speak, to see, you know, the moon that is visible. And we're going from the edge of the moon here, which technically is called the what, Dave? Is that the limb?
Well, the edge would be the limb. And whoops, I'm about ready to drop my thing here. The edge would be the limb, where the moon meets the sky, and the area where the bright part turns dark is this is caused by the shadow of, or not the shadow, but the direction that the sun is illuminating the moon, and it's like daylight and nighttime. So on the right hand side of the moon in your image, it's daytime, and on the upper left hand side it's nighttime. And the difference between those two is an area we call the terminator. And on the terminator, the shadows from the sun are very, very long. So we can see a lot of great detail usually in the terminator, and that's where we try to look, examine the different features of the moon. But tonight we have right about in the center, I'm checking this out, right about in the center of your image is a kind of a irregular but sort of round dark area. That would be the sea, Mare Nectaris. And just above that is a really pretty crater, round crater with a small mountain in the middle of it. And that would be Theophilus, crater Theophilus.
Which I can now actually zoom right into.
So that little peak in the middle of the crater is created by the impact. Uh, any of you who have ever taken a large rock and thrown it into the lake and seen that it creates this big splashing crater, and then the rock drops into the water, and where the rock fell down, there's a big peak of water that comes shooting back up. And that's exactly what happens when an asteroid or an object hits the moon. It creates the same kind of a splash pattern which makes the crater, and then quite often there's a rebound that comes back up and makes a central peak like what we see here in Theophilus. So that's kind of cool to see that. Now just up above that, above Theophilus, it'd be hard to show it tonight, but we're going into a little bit higher, right in there. And that area there is the bottom edge of the Sea of Tranquility. So right about in the middle of that shot there that you have is where Apollo 11 landed. So that's pretty interesting.
All right, let me zoom out a little bit so that we get a slightly bigger picture of the moon again, and let's just move our scope a little bit to perhaps go towards the terminator on the bottom here. Now, of course, there's always two chances I'm gonna send the scope in the wrong direction, and I immediately did that, so let me come back the other way. And we are now moving towards that try that again, moving towards that dark light transition. And I'm just going to try and again, of course, I get a 1 in 2 chance, and I got that wrong again. So this time I will just nudge the moon up there so that we can see that transition from the light side to the dark side. And this side, as Dave said, is kind of really interesting because you get to see a lot of detail in the craters associated with the shadows. Right, Dave, do you have any thoughts about that, this area? Let me see if I've got any questions. Somebody asked, can we zoom in sufficiently to see the obelisk? Yes, there is every chance that we will find one of those mysterious rectangular shapes up here if we look hard enough. I might need to put on an extra zoom lens or something, but we might be able to get there. Mars looks huge. Well, unfortunately, this isn't Mars. Mars, actually, I was looking at the other night, and is actually smaller visually at the same magnitude than Jupiter or Saturn. Believe that's correct, right, Dave?
Yes, I wasn't paying
Yeah.
attention here.
And just a quick shout out to a couple of familiar names I see floating up the chat screen there. Nice to have you up on board, Cindy. I see Woody is online as well, so nice that you could join us this evening. I'm hoping some of the guys from the UK, I felt somewhat sorry for the guys from the UK. I watched one of the live events yesterday, and they were very professionally set up. I mean, we're 2 men and a dog here, right? We are everything, all our computer equipment, our telescope is all in front of us. If something goes wrong here, like a power cord or the telescope stops working, it's the end of our transmission. But these guys, they had Zoom. It was a Zoom setup. They had 4 different people coming in. They had multiple feeds, unfortunately clouded in. There was some great information and chat, but unfortunately they weren't able to show the conjunction.
And actually it's come up a number of times tonight, and that was when it looks like the stream is not coming out. Hopefully you can still hear our voices. Yes, Jeff Flynn, no signal. We're getting that, and we don't know if that involves audio.
I think we're back live again, Dave.
Oh.
I think we are actually back live. We seem to. I'm seeing the picture of the moon move again on the stream.
Good.
So I believe we're back live again. So we were just having a few technical problems there with our internet. It just took a bit of a dip on us, but and so did the viewers.
Yes.
And so did the viewing numbers drastically fall off there. It's really interesting to see just how quickly that those numbers drop down. Anyway, for those 710 who have stayed on, uh, I'm glad you stuck with us. For the 300 that dropped off, I'm sorry that we lost you there before we could finish up. But I do believe that we're good again for the minute. And yeah, somebody suggested that we forgot to pay our Wi-Fi bill there. That was probably true. Right, so just move a little bit on the moon here, Dave. We've kind of looked at this bottom quadrant.
Okay.
I'm gonna shift now across to the sort of the top end of the moon now for our final views of the day, and I think that's probably a good point
I think so. It's
to
actually,
conclude.
we are live with the video again. I see this.
Yes.
But it is 6:30. The Jupiter sets on the horizon tonight right at 7 o'clock. And between now and then, Jupiter will fall into what we call the soup out there close to the horizon and will get very, very dim and fuzzy. The look is not near as good when it gets close to the horizon. So, we don't have much benefit in going back to take another look at that conjunction. But I was about to answer a question earlier, and that was when can we see it in various parts of the Earth? And it makes no difference where you are on Earth as far as the timing of the conjunction. The conjunction occurs on its own time, separate from Earth. And as Earth is rotating around, you will see it when the sun is down. And because of its location in the sky, you have to see it between sunset and within an hour or so after sunset. That's why we're here at this time in San Diego. So wherever you are on Earth, it would be viewable just after sunset for an hour or an hour and a half. And it makes no difference what that time zone is or what your location is. That would be the rule of thumb, that it would be from sunset for an hour or so. So I hope that helps you with understanding, observing it in different parts of the Earth.
Yeah, and I just actually swung back towards the conjunction, Dave. A number of folks were enjoying the pictures of the moon there. Some other folks were a little disappointed that we weren't still on the conjunction.
Yes.
So we will do one more shot of the conjunction here, even though it's extremely low on the horizon for us now, and then we will cool. We will. Whoops. I need to. Thank you. Sorry, I forgot to transition across there in my broadcast software. We will do one more shot of the conjunction for you guys who may have joined the stream late, even though now we are extremely low on the horizon. This is the picture from our e-finder.
Yeah.
We are, I would say, probably 10 degrees.
Probably.
I mean, it really is low on the horizon now. And so I am going to have to manually move my scope onto the target here. So just bear with me a second while I do that. We were not able to set up the automated tracking. Well, the tracking's working, but the automated positioning this evening, because we had no alignment stars when we first came out here, because it was obviously light. So we're having to manually position our scope, which is actually fairly straightforward to do. Assuming I can get the right buttons going here, and we've almost got it. So So I'm using a device called a Telrad. It's a bit like a gun sight that's on the top of my telescope here, and it just allows me to put some circles over the target, and I just ease the scope into position so that I can, right there, I think I've got it. Right, so let me see if we've actually got that. And unfortunately, the one thing we did was we placed our main power cable right in the position where I have to step across, and if we lose the main power, we will be done. So just give me 1 second here while I see what that image looks like, and I'll see if I can bring an image up.
So, Gary, while you're doing that, there was a question about equipment. You know more about this particular, Gary. Anything else you want to say about what we're doing?
No, not really. I mean, this particular setup is really designed primarily for deep sky objects, such as nebulas, globular clusters, and we do many live streams, or we've been doing live streams throughout the year to basically replace our public outreach program, which we obviously had to stop during the pandemic. And so we've gone online with this, and we've been developing this equipment and getting it ready and using it in the last few months for doing online live streams. And it's really designed primarily for that purpose. It's not really an ideal planetary imaging system, but for what we're doing this evening, it's working fine. As Dave said, I'm using SharpCat Pro.
It's 2 moons transiting Jupiter at the same time. So those are kind of fun things to do for astronomers. So, Gary?
Yeah, and unfortunately, while Dave was talking there, I did notice that the stream managed to freeze again. We are beginning to see some issues now with our internet connection here. And we're certainly well past our allocated broadcast time. We were planning to only broadcast for about an hour here, and we're obviously well over 90 minutes into this now. So I think actually we're probably at a great place to stop for this evening. As you can see from the real-time image that's up on the screen now, because of the amount of atmosphere that is between us and the planets, because they are so low on the horizon now, we are seeing some very murky images. I'm just going to back the exposure down one more time here so that perhaps we can see the rings of Saturn. But we can maybe just see them in that picture there. But I think this is probably a great time to bring the stream to a close for this evening.
I think so.
I will thank our hosts, Wei and Tom, who have been very gracious to have us here at their property and given this.
As far as our lessons for schools and things like that, but for regular public outreach, this is what we have. So if we could, we would have you here looking through eyepieces and talking to us in person. That may happen again at some time down the road, but for the time being, we try to make this as live and real as possible with things like when Gary has been at his home and we're looking for things that are in the palm tree and behind a neighbor's house, or when we step on a power cord and everything dies. These are real live situations that happen when we do these programs. So thank you for bearing with us, and thank you for being a part of our outreach program, and we hope to see you again sometime after the first of the year. Watch our website. For those who have not checked it lately, the SDAA has a new website which is vastly improved, and you may enjoy taking a look at that. So check the website for announcements. We have public calendar to announce our outreach events, and check our various social media outlets which will also have that information. So thanks again for coming. This is Dave Decker. I am the outreach coordinator for the SDAA, and this is Gary Hawkins, another one of the outreach special interest group members, who is our current technology hero.
Okay, good night, folks. Thanks very much for joining the live stream, and we look forward to catching up with you again soon. And we've still got 450 users online. So good night, Merry Christmas, Happy New Year, and I hope you all have a happy and safe holidays.
So the question